Let me welcome you to the first day of the macOS and iOS Security Internals Advent Calendar. Throughout the next 24 days, I will present to you a daily dose of small surprise lectures about macOS and iOS security internals topics. For the first day, I have selected the topic of Apple source code. Basically, we will find out that this actually exists and how to get it. The motivation behind this is that for many people that come from other operating systems, they have no idea about the question if macOS and iOS are actually binary-only operating systems. And it's a common misconception to believe that macOS and iOS are basically completely closed source. Especially for iOS, a lot of people believe that because it's more secure and everything, that it only comes as a big binary blob and you have no way of looking what's inside. But this is a widespread misbelief that is actually not true. Sometimes people relax this idea and they think, okay, macOS is not as closed as iOS, so maybe macOS has some open source. But they usually don't believe that iOS has any open source in it. And of course, for everybody who's already more keen into this topic, they will already know that this is not really true. In reality, macOS and iOS share a lot of the code, and so when one part uses an open source component, then the other part will also use an open source component. And open source is actually really used in both systems, both in the user land but also in the kernel land. Basically, most of the kernel is basically open source. For sure, both systems have some closed source binary only components, stuff that Apple wants to be kept secret, or stuff that comes from third parties. But that's just some part. And in other parts, both systems basically use general open source software that you will find on any other Unix suite system. Sometimes they use it directly, and sometimes they have a bunch of Apple-specific exchanges. And then, of course, you have additional code that is directly fully written by Apple engineers. And those things often also come in source code form. So when Apple releases source code written by themselves, it's usually released under the Apple Public Source license. At the moment, they're using version 2.0 from August 6, 2003. And all the source code that Apple provides to us and releases to the public is basically distributed via a central server, which is https opensourceapple.com. So when it comes to Apple open source, I have to give you a big warning. So just because Apple releases something as open source, it doesn't actually mean that it's fully complete. So there could be missing files. There could be actually, the files could be there, but the code is missing. And sometimes they have intentionally actually stripped code from the files because it's something new and fancy, like a new security mitigation that they don't want the world to see just yet, and so they just strip it from it. It also doesn't mean that when they give you out a specific version of the code that you will always have all versions, basically For example, they release a lot of macOS versions of code, but they don't give you the exact code that they use for iOS. So it's not all the versions and all the builds that they make available. It also doesn't mean that there are timely releases of source code. So basically, whenever there's a new macOS, you often have to wait a long time for the source code for the recent macOS to become available. And there's no real plan or a public plan when source code gets released. It is most of the time just a surprise that Apple has decided to drop a new version of the source code. Sometimes they drop just one version, sometimes they drop a bunch of versions at the same day or around the same time, but it's basically completely random, and only Apple internals maybe know about a schedule, but normally the public doesn't know the schedule. And the last thing you need to be aware of is that when you get open source from Apple, it doesn't actually mean that it will build on your system. Sometimes it's just a configuration problem in your system, or you have some missing dependencies, but sometimes it's just impossible to build at all. So now that we know that there is a certain amount of source code available, how do we get from the binary to the source code package that we are interested in? So for macOS and iOS, it's often possible to get access to the binaries. For macOS for sure, for iOS you can get them via several different means. For example, from a jailbroken device or by extracting them from the firmware updates. So when you have the files, you can use all the tools that you have to your disposal on these binaries. And one of the things you can do is just a simple strings. So when you look through all the strings, you will find certain markers that are giving you information about what kind of source code is inside this binary. For example, /bin/ls will reveal the following string. You have a string that says program is ls and project is file_commons and then a build number. So, and this is exactly the project, is exactly the package that you will be interested in to look for on the Apple specific open source server. So sometimes when you look through these string outputs, you will see that there's no program, no project, but you will find a bunch of strings of file names in the actual original source code that was used. Here, for example, you see that the file host.c was referenced, and that's from inside the bind9 source code, and this is the kind of string you would find in the binary, which will basically reveal to you that this here is apparently the bind9 source code, open source. And now you can look of the Apple server if they have this, and if they have this, it's likely a modified version, and if they don't have it, then it's maybe the original bind9 source code that you can get from anywhere on the internet. Usually strings you should look out for here is the build roots or the Apple internal string. They usually give you a hint where these strings are that reveal what kind of source code this is. So now let's say you have the source code. The next step would be to actually compile the source code. Compiling, as I said earlier, there could be a makefile system, so you just run the makefile, but usually you do the compilation via Xcode. So there's stuff like Xcode build, or you just open the project in Xcode, and then you can just build the project or the program that you want to have from a specific project. The thing is, it's not guaranteed to work at all, especially not if the Xcode you're using is not matching the Xcode that was available around the time when this code was originally compiled. Because newer versions of Xcode have newer compilers, and so it can be that, for example, there could be more warnings in a newer compiler, and the build system might be configured to error out the moment there is any warning. and sometimes there are like compiler switches that suddenly disappear in newer Xcode versions. So that means if you have an older project, it might actually never compile on a newer Xcode version. So usually it's a good idea to figure out what build system was kind of state of the art when this was released, and then try to use an older Xcode if you have it available somehow. So the next thing is, sometimes when you compile something from Apple, files might actually be missing. So it happened many times before that when you want to compile certain components, that the files are actually not in the tarball. Sometimes the reason is that there is some other unknown tarball that contains the files, but sometimes it's simply missing and you have to get them from somewhere else. In other cases, files might be actually available, but functions are missing, or they are referencing code that is actually commented out for you, or because Apple did not provide the source code. So that means not always when you get source code from Apple, it's actually complete and can be compiled. Sometimes this can be fixed, sometimes it cannot be fixed. And finally, if you manage to compile something out of the box, there's always never the full guarantee that the binary that you produce is actually having all the features that the original binary has. And this is the reason because Apple sometimes just strips code from the source code for whatever reasons. It could be a new security feature, a new security mitigation that they want to keep private. And that means that the code that you produce actually doesn't have the code that is really interesting in it. And so you will never actually reproduce the same binary at all. As you can see here, I already loaded the website into Safari, and this website used to be a very nice technical website where you can get access to the open source code from Apple. But recently Apple changed this to be all more fancy and Web 2.0 style. And usually what we were interested in is the actual source code itself. So what we will go for is directly click on the releases. So the releases would then give us the option to see what system are we interested in. So are we interested in macOS or iOS? There's also some developer tools stuff and the OS X server, the old one. So let's say you are interested in iOS. This is actually the bad news for you, because if you're interested in iOS and you look at what is actually released by Apple, you will see that only a very small amount of packages have been released here, and this is namely WebKit here and libiconf, and nothing else is basically released, which doesn't mean that iOS does not use any open source. It only means that Apple is not willing to give out the source code for basically everything that's used on this specific iOS version. So the specific build numbers that are used on iOS, they are not available. But as I told you earlier, iOS and macOS share a lot of code, so that means that actually when you're interested in some iOS stuff, you can usually find something that is very similar in macOS. When I say very similar, it basically means most of the time, most of the stuff is the same, but there could be slight differences, and it could be that in iOS there's something used that the macOS open source code actually doesn't have. And also over the time Apple keeps redesigning and redeciding how much they actually give out and so on. So sometimes certain versions of source code have certain files and then the next version don't have them anymore. So this is always like hit and miss. It's best to actually have all the code from Apple. Then you can always look back in older versions to see if they basically stripped something or not. So okay, let's assume we look for macOS, and we can see that macOS 13 is here the latest thing. 13.0 is at the moment the latest source code available. And this is what I said earlier. If you are interested in something newer than 13.0, if it exists at a certain point of time, it doesn't mean that this will be available anytime soon, because Apple keeps deciding when to release this on a completely random schedule. So let's say we look into this and see what's available, and we can see, okay, now for macOS there's a far more things that are available. And when you go through this, you can see, oh, there's so many things, and you can see we have zipcode, zlib, the set shell, we have even the Vim code, and a bunch of stuff. The question is now, what stuff here would be interesting for a security researcher? And there's quite a few things that are interesting for security researchers. Let me just show you a few things. First of all, we have the libc here. Libc is usually interesting because that's where all the C library is, and that's most probably interesting for any kind of exploit development. Then you have stuff like, yeah, of course you have OpenSSH and OpenSSL, but let's ignore that. Then you have security. You have security token D, so that's stuff that is security relevant. Yeah, you have smart cards code here. Then we have, let me see, we have the dynamic linker here. So dynamic linker, of course, is responsible for doing all the loading of libraries and stuff like that. So that's potentially very security relevant. Yeah, so the kernel extension tools may be security relevant, for macOS at least. And libmalloc, so this is the actual malloc implementation that is used by macOS and iOS user space programs. So obviously that's interesting from an attacker's point of view. We have libsecurity LDAP, we have a bunch of more stuff. Let me just pick certain things. We also have here the Objective-C runtime. So if you have any interest in Objective-C or Swift, then this here is the starting point. There's also a Swift, no, it's Swig, it's actually not Swift. No, so basically this is what you are interested in then. We have a bunch of security things here. Of course there's sudo, yeah. But when it comes to one thing that is most interesting for a lot of security researchers, then it's this last one here, the XNU, because XNU is the actual kernel used in macOS and iOS. And so this here basically would give you access to the source code of the kernel. And yeah, so whenever you have selected something that you are interested in, you can then click download, which would download the tarball directly. And alternatively, you can click on GitHub link here, which will open the project inside GitHub. So there used to be a large archive of tarballs on this same server, but Apple has decided to remove this. Nobody really knows why. It's actually, in my point of view, a very bad decision, but well, they have their reasons. Maybe they cannot, or they want to save the space, who knows. But the point is, you now have to use this GitHub and download, and best to basically archive this stuff yourself. So let's click on the GitHub for the kernel right now. So we can see we then have a GitHub view of the kernel source code. And we are not going into the detail of the kernel source code right now because we will likely see this in one of the other days of the Advent calendar. But what we can see here, for example, is we have the Apple license here. So this is the Apple public source license that I mentioned earlier in this specific version. So that's the license that the Apple code is released under. So yeah, so that's basically the kernel source code with a bunch of information, and it has all the stuff that you would normally assume from a GitHub. So you can get the code, you can basically download it, you can get it from the GitHub via Git and all this kind of stuff. Yeah, normal GitHub usage basically. However, one thing you need to understand is that this is not something that Apple actually uses internally. So you are not getting internal GitHub, internal Git logs of internal Apple development. Instead, whenever they have a specific distribution, they just push it into this Git here, and you don't have like the comments from the Apple developers internal that will tell you, oh, we had to fix this here because it's a bug or something like this. No, you only get like the whole change between the revisions that Apple releases. The last thing we can have a look at is to see in detail what are the names of the packages that we are interested in regarding certain binary files. So for example, the dynamic linker is available under user lib dild. So we can run strings on this and do a more. And we can see immediately when we do this, in the very first line, we can see here that dild is coming from project dild 957. So you can then look this up on the Apple servers and basically download it. We saw that earlier, by the way. So another interesting piece of code is the launch daemon. So when you go to sbin launch d and do the same thing again, you can see again that we have this here. So launch d comes from libxml and this specific version. So now the problem is, if you will want to try and look this up, you will see it's actually not on the public Apple servers. And so the thing is that at some point in time, a long time ago, Apple decided that they don't want to give out the source code anymore. So originally the launch D source code was available up to a certain version, and then Apple basically just decided no, not anymore, and so they're not giving this out anymore. The same is, for example, also true for things like the Core Foundation framework. For whatever reason, Apple decided at some point, no, we are not giving this out anymore. In the old days, basically Apple often just claimed that they would give out the Core Foundation source code later on. So it was listed on this website of opensourceapple.com, but it was always had a specific note there like released soon or coming soon. But this coming soon was basically Apple's speech for will likely never come out at all. And yeah, so at some point they just stopped pretending and they removed this CF source code and they're coming soon, and so they basically just don't give it out anymore. Yes, so that was this, and now I told you that this boot root thing, boot. So we can just look for that. Not boot root, build root. So we can just grab for build roots in. Let's see if we have something in sbin. So we actually have the APFS code that uses build routes. So let's have a look at this. If we do strings on it, we can see we have no program here. So let's do a grab program. So we don't have that. And so now we can do a build routes grab. And we can see here it's having Apple credential manager underscore client libs. So that's apparently the code that this comes from. And we also didn't see that earlier, so it's likely not open source. Yeah, but this is how you find out what package you will be looking for, and it's either there or it's not. This concludes the first day of our macOS and iOS Security Internals Advanced Calendar. See you tomorrow with the next lecture.